Hi there. In a previous video, we introduced the big topic of economic evaluation and comparison between engineering alternatives. And we explained the process of such evaluation and introduced the first two methods that are used, which are the present worth and future worth methods. In this video, we'll continue with this discussion and see one more example of present worth and future worth and see their application in case of one-shot investments or alternatives compared to renewable ones. The process we covered before for evaluating alternatives and comparing between them is you define the alternatives. They have to be exhaustive and exclusive and feasible alternatives. And you have to define the planning horizon, and we cover the need to make, in some cases, like we'll see later, then in some cases you will have to unify the planning horizon for all alternatives using least common multiple, LCM. You draw after that the cash flow diagrams and develop it in terms of the value of each cash flow using cost estimating or accounting or life cycle accounting. And then the fourth step is to set your time value of money or your minimal attractive rate of return, which is based on the ways you secure the capital or the money for this investment. So you secure the capital by either debt or equity. And then the fourth step is to compare, and the sixth is to select the alternative. And we started the discussion on the methods by introducing present worth and future worth methods. And we discussed that the need to use or apply LCM when you use present worth or future worth. So let's see an example here. One more example before we see a special case when we apply present worth and future worth. So here we have a project engineer with this company that's tasked to find or compare between these two locations. And we're giving the cost information for the two locations. We're not giving any difference in revenues or positive outcomes. They are basically providing the same functions. And your MARR here is 15% per year. So we're comparing between locations 1A and location B. So let's see here how to do this comparison here. We will use present worth, although you can check and resolve this problem using future worth. And once we see here, you will use present worth, and there is no mention if these locations are just one lease that can be done in 6 or 9 years. Nothing can be renewed, so we assume it's renewable. And in that case, we'll need to do LCM. So we have to apply the least common multiple between 6 and 9, which is 18 years. So if we're gonna go location A, so we'll assume that we'll go over one cycle of lease, and then we will repeat here a second cycle. So we have initial cost, there's annual lease, and there's a deposit return once we end the lease. And this will be kind of full 3 cycles of location A alternative. And we can see here that there are 7 components. When we start doing the present worth formula, I will be like plus minus 7 terms. So that formula will have 7 components. So the first one here is 15,000 at the current time. And then the second one is the 15,000, which is down payment for the second lease after 6 years from now. And then the third one is the 1,000. So once you end the lease, you get back 1,000, but in you renewing it, you pay 15,000. And then this is the same for the end of the second cycle of lease, which is in year 12. So you bring everything to the present. So you see the factors here are P given F, 15% and 12. And then the last thing, the last single sum cash flow here, which is the 1,000 at the end of the whole thing, which is at year 18. So we're dealing with P given F 15% and 18. And then the 3,500 year, initially we've seen it like different uniform series, but there is no gap really between them. So it's 3,500 for 18 years. And we're bringing the value of these in the present using P given A factor. So if you bring the values of all these factors and use them in the formula, you will end up with P given A of equal to negative 45, around 45,000. So that's alternative A. If we move to alternative B, location B here, this will be repeated, the lease here will be repeated twice, two times. This is the first cycle, and then the second cycle you get your deposit return, and then you will pay your first cost. And you can see here we have 5 components. The first cost for the first lease, the first cost for the second lease, and the 2 deposit returns for the 2 lease terms, and then 3,100 annual lease cost for 18 years. And we'll do present worth here of B, kind of following a similar process we applied for A, but using now a different factors, especially for the transition between the first and the second lease. But you'll see that P given A is the same. P given F for the end or the last deposit return is the same. And when you plug in the factors from the tables, or if you want to use the formulas, you will find that your present worth here is equal to negative 41,383. So both of them you're getting negative. So you select the alternative that's less costly to you, which is location B. So that was a quick kind of reminder of present worth. Future worth will be kind of similar structure. So you will, in location A will have 7 components, location B will have 5 components of the cash flow, but you're all using now F given something factors. So F given P or F given A. So I highly recommend that you redo this problem using future worth method, and you will find that you're ending up with the same conclusion of selecting location B. So that was a recap kind of exercise of what we covered before. Now, the only thing new we're covering here is the one-shot investment. So occasionally investments or alternatives that you are trying to evaluate or compare with others are not renewable. So it's like, it's one shot, like you have this amount of number of years and that's it. So it's a kind of finite year or number of years that you can consider this alternative. So when you use present worth and future worth, there is no LCM here. You don't apply least common multiple. You just take it as it is, the cash flow of each one. You don't repeat cycles. And you select the alternative here based on either the lowest cost, or if you have positive or negative or positive worth of the cash flow, present worth or future worth, then you will select the most rewarding one. So let's see this example here. So you have 2 investments with the shown cash flows, and they are one-shot investments, so we're not repeating here even if they have 2 different useful lives here. And your minimal attractive rate of return is given to us here as 15%. So let's see how to solve this example here. So the first thing we will decide on is present worth or future worth. So we'll say we'll apply present worth, and we'll compare here, focus on alternative 1 first. Excuse me. So if you look alternative 1 cash flow, there are different ways of handling this cash flow. First of all, you can handle it as multiple single sums. So you will have 1, 2, 3, 4 single sums, 5 terms actually. At time 0, and then 4 payments every year, so 5 terms. But you always think about efficient way of calculating the present worth here, the least number of terms. So if I look at alternative A, I can look at it as a single sum at time 0 and a uniform series from year 1 to year 4, and then a single sum, whatever remaining from 4,500, because I took out of it 3,500 and added it to the uniform series. So I'm left here with 1,000 as a single sum I have to deal with separately. So this leaves me with 3 components for this cash flow. So they will look like that. Present worth 1 is equal to negative 4,000 times 1. And then you have the uniform series, you bring it to the present by P given A. And the 1,000 single sum at the end, you bring it by P given F. So you have the values now all in the present, and you bring the values from factors or formulas, and you end up with P given present worth 1 to be positive as shown. There is another way actually to analyze this cash flow, which is I will reduce my uniform series to be only 3 years, and now the single sum will be complete here at the 4th year to be 4,500. So you see the difference here, the present worth is only 3 years, and the value at the end is not 1,000, it's the full amount of 4,500. And if you bring all the factor values and you calculate, you will find that you end up with the same amount of present worth. So this is the nice thing about analyzing cash flows. There are many ways you can do that, and each one will bring you to the same answer, numerical answer you have. So alternative 2, now we look at it. I have here a single sum at time 0, so that's easy. And then I see a linear increase in the cash flow. So right away I think about gradients, right? Linear gradient. It's not geometric, it's gradient. Question is here, is it like gradients of, it's the value of the gradient increase here is 1,000. Well, is it only gradient? So if I assume it's only gradient, I have to make sure it complies with the definition of gradient series as we studied before, so I can use the formulas and factors given to us. So if we look here, if I say my gradient starts like that, so it starts from 0 here at time 0 and kind of linearly increase, that's not correct, because the gradient series has to so it has to have a 0 cash flow at the end of year 1, not at the beginning of year 1. So this means that I have actually a combination of uniform series A and gradient series G. So don't do this mistake. Pay attention to the definition of G. It's a uniform series of increases where the first year has no increase, so it has 0. And then you will have a 1,000 increase afterwards. So that will be the formula for present worth 2. It's 1,000 uniform series, P given A factor, and then $1,000 G series, gradient series, times P given G, and it has the same number of years as A. So it has a number of years here of 6. If you bring the factors from the tables or the formulas, you will end up with present worth is equal to around $6,721. Comparing present worth 1 and 2, you will select alternative 2 because it provides more return and it's more profitable for you in this case. So that's the case. It's actually easier when you have a single shot or one shot kind of investment, because you don't have to repeat the cycles, and that's for the case when you analyze cash flows using present worth or future worth. We will see when we analyze cash flows using annual worth, we don't really have to worry at all dealing with LCM or different lives, useful lives of alternatives. So that will be in the coming video. Thanks for watching and take care.